Good evening, everyone. Hello, thank you. Good evening, everybody, and welcome to dev.talk. I'd like to introduce Chris Sherry, engineering manager specialising in web and backend systems, building high-performing, people-first teams with a strong commercial focus. He's active in the PHP community, spoken at conferences, has led digital delivery for a charity festival that raised over £850,000. Not a small number, well done. Chris will be taking us through how becoming a manager made him a better engineer. So let's welcome Chris.
So, my name is Chris. It's a pleasure to talk to you today. Thank you to Mark for inviting me to talk, and again to Kevin for giving me a hard-to-follow talk. I am a software engineer. I've been in website engineering for 14 years, and sorry, just get my timer going. I've been in website engineering for 14 years, and I work for a company called Passenger that are based here in Bournemouth. Originally we were 35 people. We've recently been acquired by a company called Masabi, who are a global company. They have about 300 employees, so there's a lot of change happening at the moment. Whilst I am a manager, I do spend a lot of my time working on deliverables as part of the team, as an engineer as well. Is my clicker going to work? Yes, it is. So Masabi work with transport providers. My part of the company works mostly with bus companies, and we provide apps and websites with features such as journey planning, mobile tickets, timetables, departure boards, travel alerts, and verifications. We do some fun stuff with maps, and we do a lot of unfun stuff with XML. The local bus companies, Unibus, Moorebus, Blue Star are but a few of our customers. And with my free time, much of it is spent organising and building systems for the Teddy Rocks Charity Music Festival, which raises money for children's cancer charities. Yes, that is Dick and Dom from the Bungalow. Yes, I am that old. Yeah, that's me trying to look cool. So, in my time as Passenger, I've progressed from an individual contributor to a line manager. Although I've held these positions at the same company, none of these were direct promotions. So each one involved applying for the job, interviewing, and getting chosen as the best candidate. I have, however, acquired over time more and more reports. So I started with 2, then I had 4, and now as an engineering manager I have somewhere between 8 and 11, depending on who you ask. Over time I've learned a lot about being a leader and a manager, but I've also learned and relearned a lot of things about being an engineer too. So hence my talk title, What Being a Manager Has Taught Me About Being a Better Engineer. In the shift from being an individual contributor to a manager, this thing happens where you have to start telling people what to do and how to behave. The what to do bit is actually quite irrelevant. Leadership is mostly about behaviours. And in my opinion, effective leaders showcase their behaviours. In my opinion, effective leaders showcase the behaviours they wish to see in others by exhibiting those behaviours themselves. In its simplest form, this is leading by example. In any given scenario, the way that I behave will be mirrored and then repeated by my team. And this will eventually become what is known as standard operating procedure. There's a couple of film clips in my slides. Does anyone know which film this is from? Office Space. Yeah, excellent film. If you haven't seen it, it's hilarious. It still stands up today. So, as I said, my behaviours will be mirrored by the team, and this leads me into the first of many learnings I want to share with you today, which is prove it. As a manager, I ask this of my team a lot. When I see a pull request, or you might know it as a merge request, and the title says that this new code does a thing, but there's no evidence of that thing, I ask this question: can you prove it? Sometimes that's code stuff, so where are the unit tests? Where are the screenshots? Can you show me the output of that file? Can you prove to me that this does what it says it does? But I'm not just here to talk about coding. Prove it also is true when someone makes a statement, such as, nobody uses Internet Explorer anymore. This feature isn't used. This makes it more accessible. This code improves performance. How can you be sure? Can you prove it? Now, naturally, this will sound like, prove it to me. Perhaps this comes across as, I, the manager, need to see evidence of this because I don't trust what my team are doing. But I don't really need them to prove it to me. If I needed that to happen every time, then I'm embedding myself in this process, and part of being a good leader is being able to establish processes that you can then step away from if your team are performing them well. But here's what I'm really saying to them. Prove it to yourself. Assumptions need to be challenged. Untested code is risky code. As humans, we are biased and we are flawed. As an engineer, if I can't prove it to myself, then how can I have any confidence in what I'm doing or what I'm saying? If I'm not proving my work or my point of view, I'm burdening someone else with the responsibility of having to do that instead. And it never feels good when someone proves you wrong. It can erode trust in what you're doing. As a manager, and therefore someone who wants to lead by example, this has become even more true, as I rely on the trust of my team, and I rely on them to trust me. So an example of this, yes, this actually is something I put in my slides today. This came up yesterday. I was making a change to a high traffic system that uses a read-through cache. Now, how a read-through cache works is on the screen. It's not important whether you understand it or not from the point I'm trying to make. The problem I was solving was the first step wasn't working at all. The whole system wasn't being invoked due to a misconfiguration of the service. There was a lot of old code that got removed over the last couple of weeks to make this work again. I fixed the issue and I could prove that the cache was being called now. I didn't write the read-through cache logic. It does have automated tests, they already exist and they all passed. But I felt some doubt, and I listened to that doubt because I didn't feel confident that I could prove how this system worked. And I couldn't prove it to myself. So even though it had unit tests that should have proved that it worked, I didn't feel that I could explain this to someone and show them how it worked. So given this hadn't worked before, this was actually came off the back of an incident due to this code not working, it would look really bad if it didn't work again after I'd said I'd fixed it. And it would look especially bad as the senior in the situation. I took this task on because of its importance, and I couldn't explain whether it worked or not. So as it turns out, this was wise. It was wise of me to spend time checking and proving to myself that this worked how I thought it should work. Because I found what I believed to be an issue, which had not been discovered before because this cache was never actually called. The automated test didn't cover one scenario, which meant that the cache never actually ended up getting updated, meaning every request would miss the cache. Now, one of my principal engineers is in the room, and he knows that what I'm talking about, and it's not this simple. This is a very simplified version of the problem we're talking about. But anyway, the intended behavior is, in this situation, actually a point of conversation at the moment. We haven't actually worked out what we intended for it to do. So I'm not actually certain myself how it is supposed to work. But regardless of that, my persistence in making sure I could prove it to myself brought this up as a topic, and now we are discussing it and we are getting into the bones of what could be a really important decision, which I wouldn't have done if I'd just gone, yeah, I think I fixed it, it works. Cool, okay, so that was my first point. My second point is slow is smooth and smooth is fast. To write a unit test, to validate a viewpoint, to research a user group, to check numbers, to profile an application, to plan for a disaster, all of this stuff takes time. That time sometimes feels like a waste, especially when you look to prove something and you find that it just proves that you're already right in the first place. It can feel like it wasn't needed. Now, this is a very contrived example that I've drawn on my slide, but if we zoom out a little bit, we see that what might have seemed slower at first, over time, might not be the fastest way at all. A great example for this is in our code bases we run static analysis, and they run on our pipelines, and they stop us from shipping code to production if it picks up something it's not happy with. This slows us down, having to ensure that the build passes per every static analysis rule, some of which can be very pedantic and fiddly. But our production line isn't getting held up by us having to stop and fix fatal code errors. So another way you might have heard this said is, cars have brakes, not so you can slow down, but so that you can go fast. Test suites, static analysis tools, pattern libraries, making tasks in Jira, these are all your brakes on your car. I put more emphasis on these things now because I've seen the slowdowns that you get if you're working on projects that don't have these in place. Now, this is a very contrived diagram. I could have just drawn the red line getting towards our done line quicker. There's no data behind this. But what you can hopefully see is that the smoother line of progress makes it easier to predict where you're likely to end up. So is smooth, and smooth is fast. Number 3, don't be late twice. Deadlines can take different forms, and some deadlines are removable. Events happen on specific days, and if the project isn't finished by that date, then the opportunity may be gone. But lots of deadlines are targets. Dates where the customer would like to have it finished, and to take longer might reduce their level of profitability, either directly financially or by delaying the next thing they want to move on to. But here's the funny thing. Nobody panics when things go according to plan. Can anyone name that film? Dark Knight. So here's an example where we've missed our deadline and there's still 25% of the work left to do. And we're being asked, when will it actually be done by then? The temptation is to choose the closest plausible new deadline to reduce that amount of unhappiness at missing the first deadline. We're 75% through the work, and we have another 25% left to do. So that's just going to take us 25% of the time, right? Now, you're probably going to expect me to say that if we'd taken the smooth path, this is easier to predict. Chris, you literally said this 4 slides ago. Well, yes, that is true. The smoother path, putting in those good practices in place, creates a more predictable timeline, which helps set that new deadline. But it still gives no solid guarantees. Even when going slower and smoother, there are unknown unknowns, bumps along the way, things that we can't control. This applies to everything, by the way, not just the macro stuff, the big project planning that we're doing. It applies to that one subtask. It applies to whether you think you'll be free to have that call with that person who needs your help. It applies to how long you think you need to book in for that meeting. These are one-to-ones that I have tomorrow. Now, I don't want them to be 45 minutes long, but I do know from history that they do tend to overrun their half-hour slots. I know this because I've been late to Harvey's one-to-one before, and because Reese has a lot to talk to me about. Putting them in my calendar as 45-minute meetings means there's a 15-minute grace period, and I'm not turning up late to Harvey's one-to-one. I might even get a chance to have a drink or something between them. Happiness is all based on expectations. When we set dates and times, we are setting expectations. Does anyone know what he says next in the film? He says, even if the plan is horrifying, when things don't go to plan, everyone loses their minds. What I've done is I've set a new deadline with an extra 45%. This way, I'm less likely to miss this deadline, and I will only have missed this deadline once. The project we've just delivered is about 6 months behind its original due date, but the deadline was set far enough in front ahead that we had a good chance of meeting its new date, even if things went a bit wrong, which they did, but we still weren't late. For the micro things, it means your meeting doesn't overrun into someone else's meeting. Someone isn't waiting around for you because you said you'd be free by 10 and you're still half an hour away from finishing up ready to help them. Now, you might be wondering how, given the title of this talk, I learnt this as a manager. Well, as a manager, your time gets used up in lots of unplanned ways, both from your line above, your manager, and also below, in lots of other ways. This can make you seem perpetually late if you're not good at setting realistic expectations of when you will actually be free for that chat or deliver that report. So you have to get good at leaving room for the unpredictable even more so. And this isn't unique to being a manager. As an engineer, this day can look very similar too. So, don't be late would be good advice. That's easier said than done. But definitely don't be late twice. Talking of estimation, tomorrow will not be more productive than today. I'll do it tomorrow because I'll have less distractions. I'll do it tomorrow because I'll have a clear calendar. I'll do it tomorrow because I'll feel more motivated. None of that will be true. Start that task today. Expect the same amount to get done tomorrow than as you got done today, or perhaps even less than you managed to do today. Base your estimations on your capacity for today, not what you wish tomorrow will be. Tip 5 is the more something can go wrong, the more something can go wrong, the more people will ignore the likelihood that it will. So one example of this is the difference between an engineer's estimate for a task they want to do versus one they really don't want to do. A task they want to do because it's an area they want to work in or uses a technology that they find really cool. These can often be underestimated because they don't want to put a big estimate on it and risk it being deprioritized or dropped or reassigned to someone else that is maybe comes in with a lower estimate. It's a race to the bottom. It can also happen when an engineer just thinks, I know exactly how to do this task. Oh yeah, that will be easy. In the words of JFK, we do this not because it is easy, but because we thought it would be easy. So Chris, this means that you're now really good at knowing when you're falling into this fallacy, right? Well, here's the funny thing. Even though I'm aware of this fallacy, I definitely still underestimate things, especially things I'm wishing will go well. But hopefully I do this less than I used to. Another example of this is code reviews. A classic scenario is that a code review of a 10-line change will be heavily scrutinized, but a 1,000-line code review will be glanced at simply with, yep, looks good to me, ship it. In this situation, of course, you should be breaking your pull request down smaller. Often, the more consequential a decision, the worse the measurement is behind it. We may monitor latency to the millisecond or count test coverage to 2 decimal places. But when it comes to a project's go or no-go decision that's worth £12 million, that decision will be based on the vibe. A red, yellow, green traffic light that someone's put in a spreadsheet that is decided based on a feeling. And it seems silly when I put it like that, but the reason this happens is because the more something can go wrong, the more people will ignore the likelihood that it will. As engineers, we need to check ourselves against this and ask ourselves, am I underplaying the likelihood that this could end badly? That this task is more complex than I think it is, that this database could disappear at any time, that this traffic spike could end up pinning the CPU. Are the decisions of the level investment being influenced by my fear of the worst case scenario actually being a possible reality? Number 6, more time estimating results in more work found. This is something I sort of knew as an engineer, but never really kind of put into a way that I could articulate to myself even, let alone someone else. But it became much clearer to me when I started paying attention to other people's estimates and how much time and effort they would put into those estimates. So I'm going to illustrate this with an example. I want to find out the distance of the coastline of the UK. So I need to estimate this piece of work. So there's actually 2 things I'm estimating. How much coastline there is, And also, how long will it take me to find out how much coastline there is? The second one's a sort of meta-estimate, the estimate of the estimate. To achieve this, I need to pick my level of estimate accuracy that I need on the time. So in project planning, we tend to use one or more of these levels of accuracy, like t-shirt sizes or weeks or hours. For my contrived example of the coastline, this really comes down to how accurate I want to be in terms of distance. Now, I'm not talking about rounding to the nearest 100 kilometers. What I'm talking about is by measuring every 100 kilometers as a straight line. So you can see here, by doing that, I skip out quite a lot of coastline because I'm just being very broad with my strokes. If we try and draw the coastline of Great Britain using 100 kilometre units, we get 2,800 kilometres. If we do the same using 50 kilometre units, we get 3,400 kilometres. We found 600 kilometres more coastline. If I do this in 30 kilometre sections, I'll find even more coastline because I'll find harbours and I'll find headlands and things like that. In 10 kilometre sections, we'll find even more. We'll find beaches and coves and things. Each time we increase the accuracy, we find more things. The more time we spend looking at the smaller details, the more we'll find. This is known as the coastline paradox. You could do this to the atom if you wanted to. It's argued that there's no definitive coastline. It certainly feels like that sometimes on projects that I've worked on, that they have no definitive length. The point is that if you estimate a project broadly, man-months for example, it'll almost always take longer than that estimate. If you break your task down into smaller sections so that you'll estimate them using a more accurate unit, you'll get something that's probably closer to the reality and most likely much larger. Generally speaking, the effort put into estimating at a smaller level is worth it, because by breaking down the work and planning out the smaller tasks, we discover complexities that we wouldn't have seen otherwise. But you also have to choose what level of investment into accuracy you are satisfied with and accept that inaccuracy. Estimates are estimates. There's times when you just have to t-shirt size things or man-month things. These levels aren't going to be accurate enough to tell you whether you'll be done in August or not, but they are useful for comparing effort for one thing versus another thing and making choice about what order you do them in. When you have enough data, even when we have enough data, we can use as measurements. Measurements are not facts. They are not certainty. They are observations that leave us knowing more than we did before. They help us narrow down something from being somewhere between 6 months to 6 years down to somewhere between 10 and 12 months with a 90% level of confidence. The goal here is not to predict the future, just to reduce the uncertainty. More time estimating results in more work found. Number 7, it's okay to make plans and then not do them. Just because you've spent time planning out how to do something doesn't make it a priority, or even give it more urgency than if it hadn't been planned before. We can be guilty of giving bias to things we understand over things we don't yet understand, because they're clearer, we can picture them in our heads. This is the Eisenhower matrix. It's a simple tool for prioritizing tasks. On the top here we have urgent and not urgent, and on the left-hand side here we have important and unimportant. And the sorts of things that go into these categories are emergencies, which are urgent and important, goals, which are not urgent but important, interruptions, which are urgent but not important, and then distractions, which are neither urgent nor important. Emergencies are dealt with now, and they are done so personally. Goals are scheduled and given end dates. Interruptions are delegated, and distractions are dropped. Now, this is only one method of prioritizing. It's a fairly good one. But nowhere on here does this factor in whether you've already spent time on the task or not. And boy, will you be happy when you did that planning for something that was a goal and then it became an emergency. It's great having a plan in the back pocket for something that's suddenly become urgent and important. Now, it's not always the case that that plan may be the best one, depending on how long ago you made that plan, but it gives you a starting point. But things change over time, from the point where you started to plan out something to when your next prioritization session may be. An important task can lose its importance, such as when a lot of other things become more important than it. That is okay. As an engineer, I've learnt that time I spend planning a task is never a waste, even if we never actually end up doing that task or project. Flexing those planning muscles and exploring the art of the possible means that when emergencies do come up, I'm well practiced in planning a solution, and sometimes I may already have one ready-made. It's okay to make plans and not do them. Number 8, most bugs get introduced at the end. Here's a typical coding scenario. The work begins. Time passes, lots of frantic coding, including a good amount of testing to make sure what I've written works, prove it. I don't want any embarrassments, I want to show my best work. I'm going to dot all these I's and I'm going to cross all these T's. Okay, it's ready to go. Now, depending on your workflow, you might have more commits in here than I do. We tend to squash our commits before we make a pull request into one atomic commit, and that's what people are reviewing. Either way, this code is a big piece of work. I've got 1,291 new lines and I've removed 6. Next up, I get some feedback from the reviewers, and that means that I have to rethink my approach a bit and come up with a different approach. I add more tests to ensure that this is thoroughly tested and test it on the staging environment. I've end-to-end tested the whole thing twice now. Okay, I've spotted a typo. I spotted a typo in the filter, above the filter function. I spelt filter wrong. Okay, nothing needs retesting here. It's a code comment, it doesn't run. There's no logic change. Fine. I'm close now. I'm almost through review. You know, nobody's ticked it yet, but we're getting there. Okay, one of the reviewers has now pointed out that I can use a different filter method that's much more efficient. I'm close to being done, and it's only a few lines that need to change. I'll quickly swap that out so I can tell the project manager that this is ready to go and I've completed my sprint on time. Without even looking at the code that's written here, I think you can tell where the bug is. It's here. Because I didn't go back and test the whole thing again. It seemed like such a fast thing to change, and I was so close to finishing that work that I didn't give it the same care and attention that I did to my first commit. So it needs to all be tested again. And if it's taking too much time to test again, maybe that's the problem. Maybe those tests, the manual testing process I have could be automated, or I could delegate the testing to another department or to a QA tester. There's various solutions, but not testing it is not the right solution. This also catches me out sometimes. So just because the functionality, does this comment I added still make sense now? So it's not just the functionality of the code that can end up in a broken state. Outdated comments can end up meaning our project is broken. Missing tests for those new paths we just added. Associated documentation, etc. As an engineer, I didn't appreciate just how common this was. As someone who reviews the work of others, I now see this so often, and now I start to try and train my team out of this problem that I found in myself. So most bugs get introduced at the end. Number 9, owning a task does not mean you have to do all of the work. So I'm assigned this task. I'm going to own this task. I'm not going to assign that task to someone else. This is my responsibility. But this doesn't mean I have to write the code myself or do all of the work. I'm just responsible for making sure that it happens and that the requirements are met. Now, I might split this down into subtasks, and those subtasks might be assigned to others so that they know what they're working on. But the reality is, at least in what I believe to be a good team, is that many people will have a part to play, whether that's pairing, reviewing, advising, etc. Importantly, though, each part of this is still my responsibility. Most of this ownership or responsibility comes down to how I communicate with others. Ownership is subtle. It's a behavior, but it expresses itself in how we communicate. These statements are really clear, but we don't talk like this as human beings. So here's some other examples. Hey Jerry, I'm working on the auth system, but the logic is a mess. Someone needs to sort this out. This is clearly passing the buck. It's also bad because it's not even clear who the buck is being passed to. Someone isn't very helpful. Better would be, hey Jerry, I'm working on the auth system, but the logic isn't clear. As you wrote it, could you walk me through it? We can put a flow diagram together to make sure I've understood what I need to change. This keeps me involved, and it states that I need to understand this because this is still the task that I own. Another example. Hey Lucy, the edit form isn't working and I'm not sure why. Could you take a look, please? It's a little bit more subtle, but who do you think is responsible for making sure this edit form works? Is it Lucy? Is it me? Better would be, hey Lucy, the edit form isn't working and I'm not sure why. Could you double check the logs with me, please? I want to make sure that I'm not missing something. There's a lot more I's in this statement. One more. So Slack and Teams are great, right? You can just ping many people at once. Everyone, the payment system is throwing 500 errors. So better would be, everyone, I've just seen the alerts from the payment system. I've messaged the account manager and I'm going to start looking at the logs. I could use another pair of eyes. Is anyone around to help me investigate? As an engineer, I'm thinking much more carefully about whether I'm taking over ownership by the way that I'm communicating, or whether I'm just passing the buck. Now, as a manager, I do need to delegate. Communication for that is just as important. This isn't delegation. This is abdication. Better would be, can you look at the payment system error and let me know what you think the problem is? Then we can chat about whether we need to take any action. I delegated a part of that task to Jim. I've asked him to look at the logs and to report back to me. But I'm still involved and I haven't just thrown this task at him and let him have to work out what to do with it. Owning a task does not mean you have to do all of the work. Number 10. Senior engineers and managers ask for help more, not less. Engineers, particularly junior engineers, are keen to prove themselves, but they fall into the trap of thinking they need to prove their ability by not needing any help. I've been guilty of this in the past, of this misconception, when I was a junior. And as a manager, I've identified this problem in others. Seeing this often has helped me identify when I'm being guilty of this too. The fact is that it's very much the opposite of this. Senior members of the team will collaborate more. They will have smaller but more frequent conversations about the work they're doing, and in a timely manner. This makes asking for help less of a big deal. And actually, it's just natural. We don't even think about it. It's just something that we do. It's part of the job. Number 11. Don't make yourself feel better, make yourself get better. So I run sprint retrospectives and I run incident post-mortems. This is where we stop and look back at what we did well, but also what we could have done better. with the idea of making the next sprint run more smoothly or the next incident not happen again. During these, I often hear what you could call comfort traps, things people tell themselves to feel better about the situation. And what I encourage people to do is think about growth. So, here's 3 examples. So in this example, I'm thinking about spaghetti code. This code base is a total disaster. Whoever wrote this had no idea what they were doing. It's not my fault the velocity is slow. This feels better. It externalizes the failure. It gives me a valid excuse for being slow and makes me feel intellectually superior than whoever the previous developer was. Better, though, would be to think this code is difficult to navigate, which means my primary job isn't just coding, it's reverse engineering and stabilization. I will document 1 module, I'll add 2 tests today. I've made the system better than I found it. And this will make us better. It shifts me from being the victim of the code to being the owner of the solution. And it turns slow velocity into a deliberate strategy for improving. Another example of, and I've heard this from various engineers, that I'm not a people person. The thought is, I'm an engineer, I'm not a politician. I shouldn't have to sell my ideas to the product manager. The technical merit should speak for itself. If they don't get it, well, that's on them for not being technical enough. I mean, this feels better. It protects my ego. It frames a lack of communication skill as a purist trait, something that's not a real engineer. But a better way to think about it would be, if I can't explain the value of this refactor to a non-technical stakeholder, maybe I don't understand the business value well enough yet. I need to figure out their API and translate my requirements into their language. This treats communication as a high-level engineering skill that I can improve on, rather than a chore. And 1 more example, so a comment from a review. They're just being pedantic, they're showing off. They have a grudge against my approach because it's not what they would do. They're gatekeeping this code base. I mean, that feels better because it turns them into the villain. It means I don't have to acknowledge that maybe my design is flawed. Better, though, would be they pointed out 3 edge cases that I haven't even considered. That's a gap in my thinking. I need to go back and study how we handle that state persistence so I don't make that mistake again. It prioritizes the integrity of the system over my fragile ego. As an engineer and as a manager, I've been on both sides of all of these conversations, and that's helped me realize that often myself, I was following a narrative that made me feel better, but never made me any better. It didn't help me improve in any way. Number 12. A well-written CV is just as important as what's on the CV. As a recruitment manager, for each role I will look at, 200 CVs. Some of these CVs may be, that CV may be for the perfect individual for the role. But I'll never know that because their CV didn't tell me that. As discussed, it's an extremely important part of an engineer's role is communication. And a CV is a communication document. So it tells me what their communication ability is like. Now, I could write a whole talk about this, and maybe I will come back and go deeper into kind of what makes a good CV and what doesn't. But the key point here is that how well you can talk about what you've done and what you've achieved shows what you're like to work with and is someone to collaborate and communicate with as well. You could have done the most amazing work, but if you can't put that across in writing, I'm not going to know. Okay, and this is my last one. Increase your tolerance to stress. So management is not a natural fit for me. There's a lot of talking to people, interpreting their words, their body language, My limited social skills are in overdrive on a daily basis. And I find each day more taxing mentally than when I was an engineer and I was trying to work out code and algorithms. Now working out people is so much more intense. My mind is in a fight or flight mode most of the time. This became a much bigger issue for me though when I stopped playing football. I didn't realise how important playing football was to my body and my mind's ability to cope with stress. This is Meatball, a football community run by my good friend and colleague Andy Brown. It's a bunch of professionals who work in digital that get together on Thursday evenings, play football and raise money for charity. When my mind and my body is in fight or flight mode, playing sports releases the adrenaline that I am carrying around with me. This resets my levels and allows space for me to take on more things. Stopping for a beer and a chat with the guys afterwards helps get things on my chest, clarify things with people who understand similar problems, like talking to people in this room does as well. This improves my tolerance to stress. It doesn't just reduce the underlying stress, it reduces the amount of additional stress that each new issue adds. And this puts me in a position that means I can handle changing requirements, mixed messages, untimely interruptions better than when I wasn't doing it. And I had no idea until I stopped how important that was. Increasing your tolerance to stress makes impossible tasks become interesting challenges. I've been Chris Sherry. Thank you very much for listening.